and welcome back. So today I'm going to start a new episode on Unit 3, that is Modeling with UML. So modeling with UML mainly focuses on system modeling. Let's see what is system modeling. Okay. So system modeling is the process of developing abstract models of a system with each model presenting a different view or perspective of that system. So it usually means representing a system using some kind of graphical notation based on diagram types in the Unified Modeling Language or UML. Models are used during the requirements engineering process to help derive the detailed requirements for a system during the design process, to describe the system to engineers implementing the system, and after implementation to document the system's structure and operation. So we may develop models of both the existing system and the system to be developed. So models of the existing system are used during requirements engineering. They help clarify what the existing system does, and they can be used to focus a stakeholder discussion on its strength and weaknesses. Models of the new system are used during requirements engineering to help explain the proposed requirements to other stakeholders. So engineers use these models to discuss design proposals and to document the system for implementation. Now let's see what is Unified Modeling Language or UML. The Unified Modeling Language UML is a set of 13 different diagram types that may be used to model software systems. The UML is universally accepted as the standard approach for developing models of software systems. So let's see what are the diagrams which we are going to discuss in this episode. So here we are only discussing 5 UML diagram types that could represent the essentials of a system. First one is the activity diagrams, which shows the activities involved in a process or in data processing. Then as the second one is the use case diagrams, which shows the interaction between a system and its environment. Third is the sequence diagrams, which shows interaction between actors and the system and between system components. Fourth is the class diagrams, which shows the object classes in the system and the associations between these classes. Fifth one is the state diagrams, which shows how the system reacts to internal and external events. So these are the 5 UML diagrams which we are going to discuss in this episode. So first we are going to discuss on activity diagrams. So let's see what are activity diagrams. Activity diagram is another important diagram in UML to describe the dynamic aspects of the system. Here, activity diagram is basically a flow chart to represent the flow from one activity to another activity. So the activity can be described as an operation of the system. Here, the control flow is drawn from one operation to another. So this flow can be sequential, branched, or concurrent. So activity diagrams deal with all type of flow control. Activity diagram captures the dynamic behavior of the system. It is a particular operation of the system. They are also used to construct the executable system by using forward and reverse engineering techniques. Activity diagram is sometimes considered as the flowchart. So before drawing an activity diagram, we must have a clear understanding about the elements used in activity. The main element of an activity diagram is the activity itself. An activity is a function performed by the system. So after identifying the activities, we need to understand how they are associated with constraints and conditions. So let's see what are the elements. Before that, we will go on to the purpose of an activity diagram. Here it performs it put forward three purposes, that is, draw the activity flow of a system, describe the sequence from one activity to another, and describe the parallel, branched and concurrent flow of the system. Now we'll move on to the elements of the activity diagrams. Before drawing an activity diagram, we should identify the following elements which I have already stated, that is activities, association, conditions and constraints. Now let's move on to an example activity diagram. So this is an example of an activity diagram for order management system. In the diagram, 4 activities are identified which are associated with conditions. So the main activities here are, the first activity is this: customer needs an order request. Second activity is receipt of the order. That is, order request system confirms the receipt of the order. Third activity is the confirm the order, and the fourth activity is dispatch the order. So these are the 4 activities that are being identified in this activity diagram. So here, after receiving the order request, condition checks are performed to check if it is normal or special order. So this is the condition check where we are performing the condition check, whether it is a special order or a normal order. After the type order is identified, dispatch activity is performed, and that is marked as the termination of the process. So after dispatching, this is marked as the termination of the process. Now the start of the process is indicated by a filled circle. See, here we can see a filled circle which is identified as the start of the activity diagram, and the end by a filled circle inside another circle. So this marks as the end of the activity diagram. Then arrows represent the flow of work from one activity to another, and a solid bar indicates activity coordination. Okay. Rectangles with round corners represents activities. See, here is the rectangle with round corners which represent activities. So they are sub-processes that are to be carried out throughout the activity diagram. So when the flow from more than one activity leads to a solid bar, then all these activities must be complete before progress is possible. See, here there are no solid bars seen. So here there is no such activity which leads to a solid bar. So when the flow from a solid bar leads to a number of activities, these may be executed in parallel. So this is how parallel and concurrent execution in an activity diagram is performed. So this is how an activity diagram for an order management system looks like. We can perform checks wherever, condition checks wherever it is possible. And here the activity flow is being forwarded to one activity. So there are no concurrent processes happening, and there are no parallel processes also happening. Thank you so much.